This is a DC boost converter. The model is XL6009E1, which is for boosting up the voltage. It has two major flaws, which I will test with my thermal camera, and I will show you the footage. And we'll test the most popular case on Maker World with PLA, PETG and ABS, how they hold on to it. So let's get into it. Hello world and welcome. First of all, let's talk about the specification and how it works. So we have a input side and a output side with minus and plus on the both sides. So you solder your leads to it. You have your source, the load, and you have your potentiometer that you regulate your output voltage. For regulating the output voltage, which you can see here, if you go clockwise, it will lower down the voltage, and counterclockwise will up the voltage. This is the MOSFET itself, and this is the diode. This is going to be the most heated up things. The input voltage from the AliExpress and in the datasheet, it's from 5 volts to 32 volts. Well, it starts at 3 volts, and the output from 5 to 35. And the maximum current output on the input side is 4 amps. The max efficiency is 94%, but they don't specify how, on what voltages and what amps. How I mostly use it is from 5 volts to 12 volts and from 12 volts to 24 volts. Because it is rated for 4 amp input, I mostly use it for 12 volts output, 1 amp, and so on. So that was how I calculate all of that. So first of all, we're gonna test it with 1 amp output and see what the thermal camera will show us. Forgot to add for the specification. On the diode side, which is the small one, the operating temperature, the maximum is 125 degrees Celsius, and on the MOSFET side, the maximum temperature is 125. So that is the limit before it burns down or blows up. These are the first results. I got it working from 3.8 volts. So on the 3.8 to 5 volts, the diode went to 86 and the MOSFET to 60. The voltage was fine, still in 5 volt range. From 5 volt to 12 volt, the voltage went to 10.1 volt. And that was only 2.88 amps on the input side. The temperatures were interesting. The diode went to 122 and the MOSFET 113, so almost the limit, or on the diode side, that like 3 degrees, and that's the limit. From the 12 volt to 24 volt, the voltage stayed, yeah, like 0.04 volts lower, but great. So on the diode side, it was 106 and 91 on the MOSFET, and the input amperage was 229. The efficiency is poor. Okay, from 12 volt to 24, like, yeah, okay, 87. The interesting part is that we have two problems. One, that the 4 amp input is not going to be possible because of the temperature. That's the first sign. And the second sign, that even below 3 amps the voltage drops significantly. So yeah, that means I need to redo the tests, not limiting on the output side but on the input side. Okay, let's do some more testing. On 2 amp limit on the input side, 3.8 to 5 looks good, 5 to 12 volt looks good, and 12 to 24 looks good. All the temperatures and the voltage, there is no drop, so 2 amps totally acceptable. The efficiency is, yeah, more or less. Let's try 2.5 amps. 2.5 amp on the input side looks to be the limit. 3.8 to 5 volt is good, but the diode is near the limit. On the temperature side, 5 volts to 12 volts is below 100 degrees Celsius, which is good. 12 to 24, the limit is the temperature on the diode side. So that means, yeah, 2.5 would be the maximum limit that should be done. From this data, I want to do 2 more tests. One is going to be the limit, how far we can push that or the diode or the MOSFET goes below 120 degrees Celsius. And the second is going to be at what point the voltage drop's gonna go below 2% of the initial voltage. I just wanted to say Happy New Year and thanks to my first 20 subscribers and for 1,260 views on the channel. I already purchased some more things to test and I haven't forgotten my home lab build. If you like the content, then subscribe, like a video, and give me a suggestion in the comments what to test or what you're interested in or what to do differently on the channel. So finding the maximum 120 degrees Celsius on whatever component, everything went to the diode. So from 3.8 to 5 volts, the maximum input on the amperage side is 2.54. From 5 to 12 volts, the maximum was 2.82 amps, but we had a significant voltage drop to 10.17 volts. And from 12 volt to 24 volt, the output voltage was fine, and the maximum amps on the input side was 2.5. So it's a mixed bag of results. Now let's do the 2% drop on the voltage side. So again, 3 tests before 2% voltage drop. So on the target side, on 3.8 to 5 volts, we got 2.59 amp input, and the diode went to 122. From 5 volt to 12 volt, we got 2.77 amp input and 114 degrees Celsius on the diode. And from 12 volt to 24 volt, we got 2.56 amp on the input and 126 degrees Celsius on the diode side. The main problem is not the MOSFET, but the main problem is the diode, which is rated for 125 degrees. So from these tests, what I see is the maximum limit on the PCB, which is open air without any enclosure. The limit is like maximum 2.5, but I would say like 2.3 amps on the input side, but in some case the limit would be 2 amps, so there's not enough airflow. Now let's test our case in PLA, PETG and ABS. I'm gonna go for 12 volt, 24 volts. I'm gonna start with 2 amps and see how the filament stands up. If it's good, then we're gonna go to 2.5 amps on the input side. After 30 minutes on 12 volt, 2 amp, 24 volt output, let's see how the PLA stands out. It's beginning to soften, but it still holds. So how this side is 50 degrees here, stands good. Here is around 50, where's the diode, and the bottom is around 60. Yeah, it starts to deform. Interesting. Okay, let's go for 2.5 on the input. After another half an hour, PLA looks bad, but first thing that we're not pulling 2.5 but 2.43, and our voltage drop is to almost 23 volts, which it didn't before. That means it's much hotter inside. The case itself, I don't know if you can see it on the camera, but it's already bowed in. Yeah, it's finished. Yeah. Oh yeah. Oh yeah. It's done. It's done. Okay. How's the side? Yeah, the side's done. Other side, which is about, oh yeah, oh yeah. And the bottom. Where's the, somewhere around here. The bottom is soft, but yeah, PLA is, yeah, it's saved up. Now let's test PETG on 2 amps. I think it's gonna hold, but you never know. Let's do it. After 30 minutes on 2 amps input, let's see how it looks like on PETG side. No, it's good. It doesn't care. Yep. Yep. Not soft, like perfect. On 2.5 amps, after half an hour, let's see how it looks like. Well, PETG looks mostly fine. I wouldn't tell that it's soft. It has a little give. but I'm impressed. I thought on 2.5 amps it's gonna start to give. Okay, the bottom is a little bit soft, like a little bit. I don't know if you can catch it on camera. Like there, like a, yeah, a little bit, like little bit. Okay, let's do ABS on 2.5 amps. On 2.5 amps, ABS. Let's see. It should be great. Yeah, it is. It is. Like no flex, no softening, nothing. Stiff as new. That side here, yeah, nothing. Here, this is the hottest place. Nothing. And the bottom, nothing. Like really nothing. So ABS for the win. So what we learned: 4 amps is not possible on this. I would say in open air max would be 2.5 amps, or let's say 2.3. In an enclosure, definitely go below 2.5. Like 2.5, yeah, like ABS doesn't give a PETG mostly, but yeah, go like 2 amps on the ABS, PETG 2 amps, great PLA 1.5 maximum. If you have any other suggestion what to test for thermal voltage or whatever, write them in the comments below, and see you in the next video. Bye.